Let's look at how to differentiate logarithmic functions. Logarithmic functions are in the form y equals log some base a x, where both a and x are greater than 0. Turns out that the derivative of y with respect to x is equal to 1 over x times the natural log of the base a times the derivative with respect to x of x. And of course x here would have to be greater than 0, otherwise we'll have a 0 in the denominator. And we can use this formula to find the derivatives of logarithmic functions. Okay, let's look at some examples. Let's say we wanted to find the derivative of log x. Well, if the base isn't shown, it's assumed to be a 10. So we apply the formula. The derivative of y with respect to x is going to be 1 over x times the natural logarithm of 10 times the derivative of x. Now the derivative of x is just 1. So this becomes 1 over x ln 10. Okay, let's look at another example. Let's say we wanted to find the derivative of y equals log base 4 of x cubed. Applying the formula, the derivative would be 1 over x cubed times the natural log of 4 times the derivative of x cubed. So this would give us 1 over x cubed ln 4 times 3x squared, applying the power rule. We can then cancel out a couple x's there, leave 1 in the bottom, and we would end up with 3 over x ln 4. Now there is another way we could have done this second example by applying some properties of logarithms. We could rewrite this as y equals 3 log 4 to the x. And so the derivative of y with respect to x would be 1 times 1 over x ln 4, which would give us 3 over x ln 4. Same answer. Okay, let's come back and we'll look at a special case. Let's look at the natural logarithm. What if we wanted to find out what is the derivative of y equals to the natural logarithm of x? The base of the natural logarithm is e. So if we apply the formula, dy dx would equal 1 over x times the natural logarithm of e. Now ln e is simply equal to 1, so this becomes 1 over x times 1, or just simply 1 over x. Remember, ln e has base e, and we want to know what that value is. Let's say it's x, or let's call it y in this case. So we know that using our properties, e to the y is equal to e, and e could be also written as e to the 1. Therefore, y is equal to 1. So ln e is equal to 1. Let's look at this graphically. This is the graph of y equals ln x. Let's say we wanted to know what was the slope of the tangent line when x is equal to 1, right here. Well, let me draw in a tangent line as best I can, something like that. To find that slope, I'd simply substitute 1 into the derivative of the ln function. So if the derivative is 1 over x, I substitute 1 in for x. 1 divided by 1 is 1. Therefore, the slope of this line is equal to 1. Well, what if I wanted to know what the slope of the tangent line when x is equal to 4? So this point right here. Again, I'll draw in the tangent line as best I can there, so something like that. And then substitute the value of 4 into the derivative. So 1 over 4 would be 0.25, or 1/4. So the slope of this tangent line is 1/4, or 0.25. Okay, let's finish off with a final example. What if we wanted to find out the derivative of log base 2 of x squared times the natural logarithm of x cubed? Using the product rule, the derivative would be the derivative of the first function, which would be 1 over x squared times the ln of 2 times the derivative of x squared, which would be 2x. And that would all be multiplied by the second function, ln x cubed, plus the first function, log base 2 of x squared, times the derivative of the second function, which would be 1 over x cubed, times the derivative of x cubed, which is 3x squared. Okay, let's clean this up as best we can. I could factor out an x there and take one away there. 2 x's there, leave 1 in the bottom. So we'd end up with, as 1 times 2, it would give us 2 times ln x cubed at the top there, divided by x ln 2, plus 3 log base 2x squared all over x. Okay, I think that's about as far as we need to go. That could be our answer. Okay, just for fun, let's bring in the graph of this original function. Now let's say we wanted to find the slope of the tangent line when x is equal to 1. There's 1, so that would be the point right there. Now it looks like the slope would be 0, would be a minimum at that point, but let's see what happens then. Let's confirm that. To do that, we'd substitute the point 1 into the derivative, or this function right here. So when x is equal to 1, y prime would be 2 times ln 1 cubed, which would be 1 over 1 ln 2, plus 3 log base 2, 1 over 1. Now it just so happens that ln 1 is equal to 0, and that log base 2 of 1 is also equal to 0. So you get some zeros in the numerator here, so our answer y primed here, when x is equal to 1, would be 0. And that fits with what we see graphically at 1, so our slope here of the tangent line is 0. And there you go.